Hi, my name's Ryan, and for my final project, I generated a terrain using a height map, sampled from various textures, added a light source, applied bilinear interpolation to my camera, and generated a skybox. The process of creating this scene involved generating a plane of vertices, generating quads made up of two triangles, and updating the y values of the vertices by sampling from a height map. Then I sampled from four textures: water, grass, rock, and snow, based on the height of the vertices to make the terrain believable. I added a light source to rotate around the terrain to simulate sunlight. Then I utilized bilinear interpolation to keep the camera on the terrain. Lastly, I generated a skybox to make the whole scene more believable. In these pictures, you can see the process of generating points, applying the height map, sampling from textures, interpolating the camera position, and adding a skybox. This video begins by showing the light source. Then we'll move to the edge of the terrain and inspect the skybox. Now we're going to explore the terrain, showing bilinear interpolation to keep the camera on the terrain. As you can see, when our camera moves around the scene, it stays on the terrain and simulates a person walking on the terrain. As the terrain y values increase, so do the cameras. So the process of keeping the camera locked onto the terrain is called bilinear interpolation. When we send our vertices to the GPU, the shader interpolates the heights of the pixels in the quad. Unfortunately, we don't know what these heights are unless we compute them ourselves. If our camera is on a vertice, it's easy to find the height of the camera, but when it's in the middle of a quad, we're not sure the height in that specific location. So what we do is take the heights of the four vertices that make up the quad that the camera is in. Then we calculate the average height between the two top points and the two bottom points, offset by factor x. The factor is between 0 and 1. If it's closer to 0, the height of the two vertices will have a larger impact on the final height calculation. And this factor is found by taking the x-coordinate and subtracting the floor of the x-coordinate. Once we get the heights of the top and bottom vertices, we apply the z-factor to find out whether the top or bottom height will have more of an impact on the final height result. And the z-factor is calculated by taking the z-coordinate of the camera and subtracting the floor of the z-coordinate. Then we take this final height and change our camera's y-coordinates, ensuring the camera stays at the same height as the terrain wherever we move.